Hi, year 11. Right, I'm going to go through the whole paper. I advise you to watch the whole thing. Certainly you should watch and correct the questions you got wrong. There are some questions you could get most of the marks and yet still give quite a poor, or a relatively poor answer, I would say. So do watch the video, particularly for the longer answer questions and the slightly complicated calculations, even if you got good marks on them. Right, so the first one's quite straightforward. Element Q does not conduct electricity, so it can't be a metal, so it can't be A or B or C, because that's where the metals are. Non-metals are in D, so that's that one, and most of you got that right, so well done. Element R has got two ions, two stable ions, R2 plus and R3 plus. Where should that be? Well, the thing about the elements in this section of the periodic table, transition metals, you know a few things like they make coloured compounds, but they can also have ions with different charges. That's not true for other bits of the periodic table, so that to be B there. There's lots of possible answers for the last question, which is around the physical properties. Physical properties are things like melting point, boiling point, conductivity and so on, softness and density, not things like reactivity, which some of you got muddled with. So if you lost a mark there, it was probably because of that. But they have, the elements in group 1 have low melting point. You know that because you've seen the elements melt, they've been put onto water. They have low density, you know that because you've seen them float. Compared to the transition metals, they float in water. They also are quite soft, they're less strong, more malleable than the elements from B as well, from the transition metals. Okay, so that will do for those ones. Well done. Question 4 is more or less universally done well. It's an aluminium atom, and you know from the periodic table, you can work it easily from the periodic table that aluminium's got 13 protons, because you look at the periodic table, it looks like that. And if it's got 13 protons, it must have 13 electrons, and they fill from the first shell first, 2 in the first shell, 8 in the second, leaving 3. Where you put the 3, where you put the electrons doesn't actually matter in the shell for GCSE, so that's the mark for that one. You have to then discuss. Lots of people got 2 out of 3 for this one, but they're very fussy about how you answer this. So most of you know that metals have delocalized electrons, and some of you explained that really nicely. Electrons, there we go. So most of you said that have delocalized electrons, which they do, and that gets the mark. You have to say, as many of you did, though, that the delocalized electrons carry the charge. Right. They examined really fussy on the third point. They said they carried it through, the electrons carried the charge through the structure, and they said if you write throughout, ignore it. You don't get the mark for throughout. Through implies it's going from one side to the other. Throughout means it's just drifting all over the place. And if you've got a metal for the last question and a non-metal, remember that metals always form positive ions when they form ions, and non-metals form negative ions when they form ions. The clue there is in the little symbol you can imagine in the middle of them there. And so they form ions if you've got metal and the non-metal that are oppositely charged, and that's ionic bonding. That would get the mark, just the word ionic would do. Okay, and you then have to answer what happens to magnesium and oxygen when they form an ionic compound. And I feel like this question wasn't answered brilliantly, but you could easily get marks, all the marks even, without doing all that well. So I'm going to teach this properly, really. I'll tell you how to get the marks. I'll also go into a bit more detail to teach this a bit more clearly for some of you, I think. So magnesium combines with oxygen. Lots of you think that magnesium, the element, is unstable because it's got 2 electrons in its outer shell. That's not true. It's just that magnesium oxide is more stable, right? So let's get that idea right to start with. But you were right that many of you highlighted that magnesium has 2 electrons in its outer shell. It's 2, 8, 2, isn't it? And when it forms an ion, it turns into magnesium 2 plus ions, because it's got 2 in the outer shell. And when metals form ions, they lose electrons, and you're right, many of you said that they end up with full outer shells, okay, which is true. I'll talk about why that is though in a second. It's not suddenly that 2 plus ions are stable and the magnesium atoms are not stable. Oxygen atoms have 6 in the outer shell, and it's a non-metal, so they tend to gain electrons. So when they do, again, they do tend to form full outer shell, so we end up with an oxygen 2- ion now that has the same electronic configuration as it happens as a magnesium oxide ion. So you get marks for saying the magnesium loses 2 electrons, 1 mark for saying they lose electrons, 1 mark for saying oxygen gains electrons, 1 mark for making it clear that 2 electrons are transferred from the magnesium to the oxygen. Okay, and then you get the final mark for saying you get magnesium ions and oxide ions. So that's the 4 marks. So that loss, gain, 2 electrons transferred, and 2+ ion and the 2- ion form. That gets all the 4 marks, but that's not really enough, I would say, to really understand what's going on here. So the reason that ionic compounds form is that when you form those ions, they suddenly have this very strong electrostatic attraction between them. That's the driving force. The driving force isn't the full outer shells. They do tend to form a full outer shell because that allows them to have the lowest possible or the most stable possible outcome over all the possible outcomes there could be. Right, but anyway, that's I'm going off on one, so I'll stop. But you get 4 marks as I described for there. I'll do.